Hey everyone, welcome back to our Tuesday live stream from the Elastic live virtual user group. I am your host, as usual, Jay Miller, a developer advocate at Elastic, and this week is going to be a party because for the next hour, I have probably the person outside of my team that I talk to more than anybody at Elastic, the one Seth Larson. Seth, what's up, man?
Doing good.
I haven't messaged you too much in the last week just to get ready for this. We're going to be talking about one of my favorite clients in the Elastic sphere. But before we do that, welcome to everybody that's in the chat. Be sure to give us a good howdy do and let everybody know where you're coming from. And yeah, let's jump in first, Seth, by telling everybody kind of how you got to Elastic.
Oh, yeah. So getting to Elastic involved being a maintainer of a lot of open source projects, most notably Eurolib 3, which is an HTTP client library. It's the most downloaded package on the Python package index. And I've been the lead maintainer for, I think, 2 years now, maybe a little bit more. And then, so Eurolib 3, obviously it's used everywhere. And I had some experience with API generation with the VirtualBox API bindings for Python. And I think those two just combined to make me a good candidate for doing API design for an HTTP API. And so, yeah, started at Elastic. It's almost 2 years ago now, I think. And yeah, time has really flown, to be honest, but it's been a really great time. So
it is absolutely flown by. In fact, as we speak, today marks my 1 year at Elastic. So like I remember having like the conversations when I first started of just like, oh, so you do urlib 3. No big deal. It's only the most popular and most widely used, module in the Python package index. No big deal though, right?
yep. It's it's a fun one to maintain. Having the immediate impact, like being able to make some changes in that module and just being able to impact like millions of people with one deploy. It's fun and it's frightening and it's lots of different emotions come into all parts of it. So it's really good. So
I love the tweet that you sent out that said like, oh, when another major framework in Python gets an update, you know that urllib 3 is probably running something behind the scenes, which means urllib 3 also gets a giant download package that day.
yep.
Um,
Yep.
it's funny. The whole world runs on Seth, I guess. We'll have to
Thank
keep you
goodness it
busy.
doesn't. Thank goodness it does not.
But
I only have so many hours in the day.
awesome. Well, speaking of, we're going to talk about another package that you run because you're also responsible for the Python package, which I did a live stream on a while back. It probably, it did like half the justice that you could have done for it, but I think we covered the basics. Send requests, use bulk, life's easy, right?
Yep. No, the other modules I maintain at Elastic are the Elasticsearch Python client, the Enterprise Search Python client, which is like app search, workplace search, and then I also maintain Elot, which is kind of maybe part of the focus of today, but it's more of a data science window into the Elastic stack. So yeah.
Yeah. So let's dive into this. So I remember you mentioning Eland being very similar to pandas. And for those that aren't in the Python world, pandas is a data framing tool and kind of the pillar around data science in Python, or at least one of the pillars.
Yeah, definitely. No, Pandas is an amazing library. The data science community wouldn't be where it is for Python if it wasn't for like NumPy and Pandas and Matplotlib and all of these amazing libraries. It's one of the most quoted things that people love about the Python ecosystem is its libraries.
So I guess the first hard question, and by the way, speaking of questions, if you have questions for Seth, myself, about Elant or any of the other tools that we have, if it's another tool, then we have the perfect place for that. It's actually our Discuss forum. But if it's related to what we're talking about today, feel free to ask it. This is an AMA. We're going to be bringing up questions as they come in. But since Elon is supposed to be this pandas, but for Elasticsearch, why not just make it a plugin? Like why not just make it an extension of what something is doing? Why is there this is a dedicated client and it does dedicated things?
Right. Yeah. So I think one of the big ones is the dependencies. So because Elot pulls in a whole bunch of different dependencies, this is kind of like, why isn't Elot just a part of Elasticsearch DSL or the base client? The big one is dependencies. Because it uses pandas and NumPy and optionally a whole bunch of like machine learning libraries. That was really one of the big motivations for keeping it separate. Another thing is that it actually originated from a completely different team. It originated from the machine learning team within Elastic, and then kind of got adopted by the language clients as like, okay, we'll kind of help this go forward, promote it, make sure that it gets all the love that it needs to go into like general availability. And so that's kind of the story of why two modules, why two packages.
Nice. I think we learned a few weeks ago that like one of the biggest users of the Elasticsearch clients is Elastic, and like the Elastic teams, like Kibana is a big example of like how we can just beat the JavaScript client, to bring it down to its knees and just find more and more use cases for it. So it is cool to see like we're using these tools, and then we're like, hey, everyone else in the world could probably use this too. Why don't we just kind of give this over to the languages team and then let them kind of continue to update it and maintain it, and we get a benefit from it, but also the rest of the Elastic community gets to use it as well.
Yeah. No, there's a lot of internal Python usage at Elastic. So Cloud uses a lot of Python for a lot of their like aggregation job, like background scripts. And then there's also the performance team, which uses the client for a tool called Rally, which is like a macro benchworking framework that we run every night. And we look for performance regressions and all of these different Elasticsearch features. And I know that the like analytics, so like cloud analytics, they use Python extensively. So yeah, we have tons of internal users for every single language client, which is really cool because you get people before you put something out new, you can just tap all these shoulders and be like, hey, can you make sure that we're doing the right thing here? And it's really great having internal users.
Well, I just added a note to myself to make sure we try to find someone on the Rally team to come onto the stream and show us how they're using it, because to me, my biggest weakness in Elon, which I'm hoping we'll get to later today, is that machine learning bit of it. I work with a lot of data, but it's always like a lot of a little data and it's never related. So, it's always kind of hard to be like, I'm going to learn PyTorch today and just like, or
Yeah.
I'm going to learn this, machine learning library. And yeah, so let's jump and talk about the usage of Elon at the basic level. What are some of the things that you can do rather easily with Elon that makes data consumption easier?
Yeah, so I think one of the biggest features of like Elot, so there's two big things that Elot does right now today. It does like data frame support, which is essentially you have data in Elasticsearch and you want to manipulate it, look at it, just use it through this lens of pandas or data science libraries. And then the other one is machine learning. And so machine learning, there's all of these APIs that Elasticsearch has that are machine learning related. And so how can we interface with those? How can we bring in third-party modules into Elasticsearch to operationalize them? So those are like the two pillars. I would say that a lot of people, it's pretty split, like what people end up using Elot for. It's one or the other. I actually haven't met a ton of people that use both besides like internal teams. So I would say that like the basic stuff you can do is if you have data in Elasticsearch, you can create a data frame that points at that data and then just explore it in like a Jupyter notebook or in a REPL. That's one of the big things that I kind of like to do with Elot. It feels kind of magical almost because you know that the data is like in the cluster and it's not getting pulled locally, but it feels like it's local. So that is like a really magical experience. And then the machine learning aspect, like you said that you don't know a ton about machine learning. I also don't know a ton about like the super details about machine learning. I know the basics. And so what I know is that Elot is really great at, you have a third-party model that you want to like deploy to something that is actively looking at your data as it's coming in and making decisions about that data, and then like recording those in those documents. And so we have this concept called like an ingest pipeline. And so you can basically put this structure in front of an index or a data stream or whatever, and then it'll modify your data as it's coming in. And so machine learning can be a part of that pipeline. And you can have like a hot swap model. So you have a model living in Elasticsearch, and then whenever you want to update it, you just say, okay, here's the new version of the model, and then the processor will start using that new version. And so Elot is kind of like the glue between, you have a third-party model that you trained yourself to put it in the pipeline and have it start impacting my data. And I mean, there's a bunch of like little APIs that you kind of get, like, oh, I want to delete this model, or I want to, see which models I have. But the big one, like the super magical one, is I have a model and I want to deploy it to Elasticsearch. Or there's also this little API that lets you take local data and then test it against an Elasticsearch model that's already deployed. That's also something that like people have done to like, oh, I want to test my model that's in Elasticsearch to make sure that it matches the one that I have locally. So
That makes sense. And I think one of the things that, and maybe we can even see a demo of this, is when you talk about like IO or like ingestion of data, it's that power, it's that pandas like power that I love with Elon, because Elon just makes working with data frames easy. Like if I have a data frame and I need to get a bunch of work done on it, the fact that I can say, hey, let's let pandas do all of the applying and merging and mutating of work, and then let Elon work with that resulting data frame instead of having to then go out and export it and, oh, I need to convert this into JSON and then just load it in from Elasticsearch Pi. It's cool to just be like, all right, Elon, you've kind of ridden with me this whole route. Pandas has done a bunch of work. Elon, take this data frame and just make it work. Like make that happen. And then on top of that, you've taken a lot of concern or a lot of consideration into how do you blend those Panda isms and the Elasticsearch isms, because both of them are very ismistic, I guess. I don't know. That's a new word I've coined. But they each have their own like ideas of how they want to work. And you've found a good way to blend the two so that it doesn't feel like you're learning two different things. It feels like you're doing both at the same time. And it just kind of makes sense and rolls. So if you have like a demo of that, that'd be perfect. But otherwise, we'll have to work with the word soup that I just made.
yeah, I mean, I have a little script in front of me that I use to upload some data, some public data. I can share that if you'd like. And just
Absolutely.
kind of, we can just show it off. Let me pull that up. There we go.
While we're doing that, a good hi to everyone in the chat as we're getting set up here. But it looks like we're here. Can you make that a little bit bigger?
I sure can. How's that? Is that big enough, or is that too big now?
No, that's great.
All right. You'll have to tell me when I am live on that side.
You're up and running. You're all set. So it looks like up, and I think as you did
that I do.
Hold on one second, Seth. You're cutting in and out here. Let me do some stream maintenance of my own. All right, I think you're good now. Oh, okay. Try it now.
Okay. Sorry, y'all. Yeah, too many bytes going over the internet. So right now I kind of have a client instance right now that's configured with Elastic Cloud. So I have like my cloud ID and I've authenticated. And then I have this data here, which this is just like a big CSV file that I downloaded from the NYC. It's like restaurant health standard data. So I just downloaded that. And this is that raw CSV with no modifications. And I'm kind of just into pandas the way that
Hmm.
it into format that Elasticsearch is going to track. Rename more sense. Like DBA doesn't mean anything to me, but business means a lot more.
Hey Seth, I think
It's
we're
like
still
date.
running into some connectivity issues. If
Oh
someone
no,
in the chat can let me know, are y'all having connectivity issues on your end as well?
it might honestly be me too.
Um,
You never know.
yeah, I'll say I'm in San Diego where it never rains, and we had a thunderstorm where the power went out, for like 4 hours this morning. So it could very well be my end as well. But while we're waiting for someone in the chat to let us know if we're having connection issues, I kind of just want to go back through what you were mentioning there.
Sure.
If you can scroll up a little bit. So you took some data. It was in a CSV file. I have learned that tends to be how a lot of public data comes in. I actually have a conference talk coming up in like a month about how to work with public data, and CSVs are very emphasized in that. But then what you did there is you did a read CSV. Um, why not just throw it directly into Elot and say, all right, Elot, do your thing? Like, why did you bring pandas in first?
Yeah, so throwing something into Elot is essentially putting it directly into Elasticsearch. So a lot of times what you'll have is you'll have columns that maybe you don't need, columns that like they wouldn't make sense for you. So things like long ID fields that just don't mean anything to you. So it's not data that you want. The other thing is like if your data is not in the format you want. So like a lot of times dates, for example, if you live in the United States, your dates will be month, day, year, and that's like a horrible format. And so you want it more to be in like a native date format that Elasticsearch is able to act on like immediately. So if, for example, year, month, day. So that's something that I always do, like rearrange the dates so that they're formatted nicely. Geo points, same thing. Like Elasticsearch wants your latitude and longitude to be together. It doesn't want like one field that's latitude, one field that's longitude, because then you would have two numeric values that like can't be used for like distance queries or any sort of geospatial query. So you definitely want that geopoint type. That's kind of like the bulk of what this is.
Yeah, and to kind of add on to that, I mean, when we mentioned earlier that like pandas has a lot of these things in place. I mean, one, the parse dates flag, just in general, to me has been a lifesaver because without having to do mapping templates or doing kind of this hard defining of this field's going to be a date time, you can just say, "Hey, pandas, when you read the CSV file, parse the dates." And it will automatically not only recognize that there's a date there, but it'll set the type to date time so that when you do go to upload it into Elasticsearch, Elot will pick up on that and make that conversion for you. And I've definitely run into that location question of like this needs to be one location. I like how you did that though with the zip. Normally I have like a separate function and then I just do an apply, which I've heard you probably shouldn't do a lot of applies on your data. So I'm actually trying to figure out better ways to do that.
I mean, if anything, this is almost the same as an apply because it's still pulling it into Python. So anytime that you have like a huge data set, you want to stay in like pandas land. And so doing an apply is essentially like applying Python code to something that otherwise wants to work in C. So anytime you can use native pandas functions to do your operations, that's best. But in this case, I don't think there's really anything you can do to like do an F string to concatenate values and all of that. So
Yeah. Let's scroll down a little bit and see where we're going from here.
sure. Yeah, so
So
this is just the dates. And actually, I had no idea about the whole parse date. That is actually wonderful. I'm going to be using that in the future.
yeah, I think that it's one of those things where like as long as it works, like it works.
Right.
I know sometimes it tends to work with like ISO formatted dates. Like if someone throws in next Tuesday, it's probably going to be like, nah, that's a string. But
I
it'll at
would be
least work.
really impressed if it could figure out the context of next Tuesday, especially based on the current date. Like if it's Tuesday tomorrow, me saying next Tuesday doesn't mean tomorrow. Oh man, someone write a library for that.
That's where you start looking at date util parsers, like, and then again you'd have to throw an apply in there. But
Yep.
let's sit on this spot here because I think this was the thing that I really had to learn. So Elon uses keywords as the default for text, right?
Yep. So text fields default as keyword. And so keyword, if you don't know anything about the distinction between text and keyword in Elasticsearch, keyword fields are really fast at equality. Like you can do equals equals and that will work extremely fast, but then it won't give you the things that you're kind of like no Elasticsearch for, which is like full text search. So that would be like a text field. So a lot of times what you'll see is people will have like action or a business name will be text, but then they'll also do a subfield that's a keyword just to get the best of both worlds. But in this case, like we're just kind of assigning types to each one. So
And
that's
that
the
and
difference.
that Elon decision to go with keywords being the default, is that just based on Elastic's behavior with the rest of its APIs, or is that kind of, hey, pandas, we had a long conversation a while back about the idea of query versus ES query and how pandas is really looking for Boolean match values. So was the decision to go keyword over text based more on pandas or based on like Elasticsearch behavior?
I think it's based more on Elasticsearch behavior. So keywords, if you could imagine, they're a lot smaller to actually store. And I would say a lot of the string values that you get in like data sets are not ones that you would want to be doing full text search on. Like for the most part, they're going to be values that you are going to want to do either equality or they're like an enumeration value where it's like for in this case, it's like grades. So you have like A, B, C, D. And so I think that's one of the big motivators for that is just like size. And also if you were to put text into Elasticsearch, it would be keyword with if you just didn't tell it anything. Another thing that is actually happening in that area is, so I had like a suggestion that like, okay, if there's fields in a string like column that are huge, like should we just use text because like they look like prose basically. So that's something that I'm thinking about, and it is something that I think that Elasticsearch does if you go through a certain API. But I don't quote me on that. So yeah.
This, by the way, for those that don't know, this is the community channel where we say things and then usually the answer is always it depends or
Oh
let me
yeah.
get back to you on that. So
Yeah.
everything we're saying here is often just based on our experiences, not anything that someone has told us to say.
Hmm.
Uh, but yeah, I think that the ES type overrides when you do pandas to Elot to me was it's something that I constantly forget because again, pandas does such a good job already of just doing type inference. But as someone who does tend to work with like web apps and trying to do, I think my most used query type is simple search string. So like that works with text. Keywords are just not friendly for that. I mean, they work, but you're going to run into some confusion there. So I think using these type overrides to say, yes, I know normally this is a keyword, but at the end of the day, like I kind of need it to be text. It's not impossible to do, and it's actually really easy to do compared to, another option, I guess, would be creating your index using Elasticsearch Pi, setting your mappings when you create your index, and then trying to append all of the data from pandas into it at that point, which I've only discovered works sometimes. There's a lot of room for error there.
Yeah, definitely. And it's kind of it's the tough position between what is too magical, right? Like Python users, I would say in general, like if you look across different languages, Python's one of those languages where people do expect a good amount of magic, for better or for worse. I mean, obviously explicit better than implicit, but in my experience, a good amount of magic is kind of expected by users to have like that good Pythonic experience. And so it's tough to strike that balance of what is too magical, like how am I making too many decisions for the user? Yeah, so it's a tough place. It's a really tough place to be where you're like, okay, I really want this to work in 99% of the cases, but then I also need to make it configurable for the 1% of cases. And I also need to somehow document it so that users know, like, okay, you're in that 1% case of you need that to be set. Definitely the whole keyword versus text is an area I would say that that's probably one of the biggest ones that is like, okay, you need to know a little bit about Elasticsearch at this point in your juncture of using Elot. Like you can't just know about pandas and then have all of the features of Elot work perfectly if you don't know how to do like what types Elasticsearch has and then what the differences between those are. So yeah, there's still a little bit of like, you need to know Elasticsearch to do Elot like to its fullest potential. But I would say that like, if you just have a data frame and you just like throw it into Elasticsearch, like you'll still be able to be kind of dangerous with that. And the nice thing is it lets you like iterate. And, you know, if you want to just upload your data, like a small subset of your data, just try it out. And then, okay, that looks good. Now let's upload all of it. Like that's also totally valid use case. So.
Yeah. And this is why I love doing these live streams in the middle of the day around everyone's lunch break. We actually have people from the machine learning team that get to come in and provide some input. So Ben tells us the default to keyword is we had to choose a default. So one, you had to pick something. Pandas filtering on text is usually equality, which is super friendly for keywords. And datasets for supervised models, not natural language processing, is usually keyword based. So it's like everything else is pointing towards keyword. Elasticsearch uses keyword by default. It's kind of a win-win to go that route. It seems obvious. But I will also mention, he said the idea of switching to text based on length and number of spaces is a nice idea. Yep. To which I will respond with, remember, all of our clients are open source and people are invited to contribute. Go to github.com/elastic/Eland. And from there, you can make your opinions known. But let's
yeah, I would say that our like community contributions for Elot have been like wonderful. I have a lot of fun every time I show up and there's like a new pull request or something. So yes, please, if you're watching and you want to try getting into open source, I don't bite. I promise. I'll be nice to you. Okay.
And I don't know. I've made contributions to your clients before.
Don't give it away. Don't give away the ending.
No, it's definitely a good time and everyone's super helpful with that. The last part of this, so we're using pandas to Elot, which is doing a very simple thing. It is taking a pandas data frame and it's turning it into a body of content, some docs that we're going to upload into an Elasticsearch index. And you have this ES-if-exists replace. What's the default behavior of like, if I forget that line? Because I feel like I've done that before and I didn't get the results I was thinking of.
Yeah, so the default is it'll just fail. So it'll just complain. So this ES-if-exists basically is saying, okay, if there's already an index in Elasticsearch that you are trying to insert data into, like what do we do? So the default is to fail. It just raises an error that says, hey, there's already an index here. You got to do something. Either delete it or set ES-if-exists to a different value. So if you, in this case, replace, it does exactly what it says on the tin. It'll delete the index and all the data that's in it and then replace it with whatever data you just passed to pandas to Elot. And then there's another value, which it's not really a great default because you never know, like when you get past a new data frame that has like some slight changes, you can't like merge the mappings essentially. Like if there's a mapping difference, you're going to have a bad time. But the other one is append. And so like if you have data that you've added to Elasticsearch and now I want to add some more, you would do ES-if-exists append and it would append the data to it. And it would also check to see that the mapping matches reasonably well. I don't know if it's an exact match because there needs to be some sort of like there's some massaging that happens on the Elasticsearch side. For example, if you say that the mapping is like a date, time, or an integer or whatever, but your data is something else, it will try to massage it into it. Unless you tell Elasticsearch explicitly to not do that. But it tries to be helpful. So
I like that. And yes, that is, I think that with this, what we're realizing is usually this is getting the data in. This isn't working with it. So, you're not, to my knowledge, you're not making a bunch of mutations by bulk indexing things over and over and over again. I mean, if you're going to make a change, you're going to make that change, but it's not going to be like, oh, I took 5 million documents, mutated them all, and then re-indexed them on top of the existing architecture with a new version update. Like, I think the smarter role there is to just re-index, have it be, version one again, and just call it a day. And that said, one of the things I do like about Elot, which I want us to kind of start segueing into, is when you're working with the data, you aren't limited to just one index. Just like with Elasticsearch, we support index patterns. So you can say, I'm going to grab, data once a week, and it's only going to be that week's worth of information, and just index after index after index after index, and then allow Elasticsearch to say, all right, I'm going to do a search on these, 52 indexes that we've pulled in this year, and let it do the work for you. You don't have to worry about like, oh, I need to constantly overwrite my existing data or append to my existing index on, one after another every single week.
yeah, definitely. And so there's this concept in Elasticsearch called a data stream, which is basically exactly that. It's how can we package tons of indices that have like some sort of time or like freshness component to them, pack them all together, but then make them as easy to use as just a single index. And so there's some more testing I need to do for Elot specifically with data streams, but in theory, they work right away out of the box, and you just point at it as if it was an index. And so that's like a really nice thing that you can do, especially if you have data that's like continuously growing, but then you only really your care about the data scales with how old it is or how fresh it is. Data streams are a really great like solution for that problem. And you'll actually find that quite a lot in Elasticsearch. So like things like logs and metrics, those are big use cases for Elasticsearch. So like data streams, really big part of that. And so in theory, you can use Elot with that just the same way you'd use it with just a normal index with static data in it. So
yeah. So let's take that as a way to kind of segue into like, okay, we've got our data into Elasticsearch via Elot. How are we now working with that data still using Elot?
sure. Yeah, so I have, if I scroll all the way up to the top, is this text size, or that might be too big. Is that text size fine?
Maybe a little bit smaller. I think
A little
you
bit
got some
smaller.
cutoff. Yeah.
Okay, how's that?
Okay, that's good.
Okay, so this is just a Jupyter notebook that I have running, and it is connected to that exact same cluster that I just uploaded that data into. So this is kind of just showing off that, hey, yeah, the client, it's actually talking to an Elasticsearch cluster. And then this is kind of just like how that mapping, that index mapping looks. So you can see all of these, like the text that we overrided for business, all of these other like types that it just decided. So as you can see that Jay said, the keyword is a popular one. But those actually all make sense to have as keyword. And then the settings, that's just normal Elasticsearch stuff. So now let's create our first Elot data frame. So that was pretty uneventful. All it does is you give it a client and you give it an index pattern. So in this case, this is just a single index that we're working with, NYC Restaurant 1. You can give it like a pattern of indices, so like wildcards. You can give it a list of indices to work with. It'll work with them as if it's one index. It does check the mappings to make sure that they're all compatible with each other. Otherwise, you're going to run into problems where your data is just like all sorts of different shapes. And then so if I just like run this data frame to just kind of like show off what the repr of this data frame is, you'll notice that this looks very similar to what you would find if you were just like a data frame from pandas, and it fully native, well, my scrolling is not working. Fully native, so you can like see all of the different columns, which is kind of nice. Integrates with Jupyter. And then, so if we go to the bottom of that, it's the same thing. Like you can run info on it, and you can see like, okay, here's all of the pandas things that have been figured out from the Elot to pandas side. So like this business field that was text in Elasticsearch is object because pandas doesn't have, I think they have some sort of native string type now. I've seen some rumblings about that on Twitter, but I haven't used it yet, so I don't know anything about it. And then, you know, standard stuff like date times and integers and floating values, those are all there. And you can see this is the size of like all of the data on Elasticsearch. It's almost 100 megabytes. And then in terms of the memory usage locally, so like all of the storage here, it's only 64 bytes. So very small. The data is all living in Elasticsearch. We're not pulling anything locally just by doing these queries. You only get the results.
Do you know if you just did that read CSV from pandas, like how large the memory usage would be there? I mean, would it be the 99 megabytes that exist?
Let's see. So let's do, if I were to do, just pull that data to locally. Let's try that.
Okay,
so this method here.
Now you're showing off.
So this essentially just asks Elot to say, hey, that data that I'm looking at right now through the window that is like into Elasticsearch, can you just hand that to me as a pandas data frame? So this might take a while. I don't know. We'll find out. It'll take a little bit because it's got to download 100 meg of data at least. Because so that 100 meg is not like total size. So I'm not sure what this is going to be. It's just like what the shards are reporting as how big it is. So it might take into account replicas as well, because that's an Elasticsearch concept that allows for like high availability. Essentially, if one node were to go down, then it would immediately be able to serve from a replica as opposed to just being like an outage. So yeah, this might take a second.
While we're waiting for that, let's just keep going. One of the things I wanted to kind of highlight there was that we get the idea, and this is something that I often emphasize, and I think a lot of data scientists are looking for these solutions, especially when they're starting out. Even when you look at modules like Dask and kind of those things, is what happens when I have too much data? What happens when I'm trying to load some information in? It's 3 gigabytes, or as we were talking with George Kobar about ILM, we're talking about possibly terabytes of data. Like, if we need to work with this data, I don't want to have to load all of that into memory. I don't have a terabyte of memory to load. Like in this, we're looking at 35 megabytes compared to, what was it in Elot?
It was 99, so it's probably counting the 2 replicas is my guess.
Okay. So I think that the good starting point is I have a bunch of data. This is just memory. It's not memory plus storage. So like, unless you just got terabytes sitting, on your computer at home that you can just lend and have it being queried by pandas all the time, in that case, more power to you. But to me, I love letting, a server where I have ILM policies, where I have all of these things to make sure that I'm keeping the data that I need to keep and I'm managing my storage efficiently. And then on top of that, I'm still able to interact with that data as if it were a pandas data frame.
Yeah, one of the cool things about Elasticsearch is like the horizontal scalability and the ability to just be like, okay, I have another cheap machine with hard drives plugged into it. My cluster just got bigger. And then like things working pretty well, because you can even tier individual machines to be like, oh, I want this to be my hot data, the data that just came in. Maybe I have that hooked up to like SSDs or something. And then you have like cold data or warm or whatever you want to call it, where you have it like hooked up to spinning disks, if those are even relevant anymore. And then like having like ultra, like super, super cold, where we have it called frozen, and like searchable snapshots. Those are other Elasticsearch concepts, where you actually have the data living like on S3 or Google Cloud Storage. And then there's like a cache, but it's like still searchable. And so like if you were to try to access that data, like it would take a little bit longer, but not that much longer. It would take minutes as opposed to milliseconds. And so that data is like almost infinite storage, right, with S3 and Google Cloud Storage. So like the idea of operationalizing all of these different like classes of data, like access and storage and how much ability you have there, Elasticsearch is kind of really good at that. And that's something that is really cool. And so if you have like that tons and tons of data use case, Elasticsearch is a pretty good fit for that. And then Elot is just like icing on that cake, basically, where you can keep that same API that you really like with pandas and all of these other data science libraries, and just use it natively as if the data was on your local machine. Yeah, there's a lot there. It's quite fun. A lot of people seem to like the magic. So,
And to double down on what Ben said, I'll bring it back up. You can do two pandas after you do your aggregating, after you do your querying. So again, if you're working with, a 1.5 terabytes of data and you only need that small segment, you don't have to pull everything down and then start running pandas, methods on it. You can say, okay, Elasticsearch, give me exactly what I need. Okay, now that I've got it, let's just make this one part of data frame. And honestly, I don't know if I've ever used two pandas. Usually I can just work with it being in a data frame that's supplied by Eland. I know that there are a couple of things that pandas can do that Eland doesn't do yet, but I think that the need for two pandas is becoming less and less, every single week. Every time there's an update, it's like, oh, we added these, all of these modules to make it more complete with what pandas is doing.
right. Yeah. So Elot has this whole like idea of how it is going to transform what the data that's in Elasticsearch into a data frame. And so anytime that you kind of like move away from that idea, so for example, the example that I always use is transpose, like rotating your data on a diagonal. Like that is not exactly something that happens in Elasticsearch. Like that's definitely a post-processing action. And so we try to push a lot of the post-processing stuff like not as applicable to Elot, and instead like you just have to opt in to the like I want to pull my data locally now. So instead of being too magical and then you accidentally like trip over a landmine that pulls all your data and does all these operations and becomes this super complicated thing, instead you have to like opt into it and say like, okay, now I need this exact pandas API to do what I need, but it's not implementable in Elasticsearch, and I'm not going to even like expect people to have this implemented in Elasticsearch, because the paradigm that we use is essentially a document is a row and a data frame is an index. And so and like fields in Elasticsearch are columns in a row. And so if anytime that you deviate from that, then it's not going to be implementable essentially. So like iLock is a common one that gets asked. Transpose is the one that I use. Yeah. So anytime that you run into that, that's kind of where you'll have to start using two pandas. So here's kind of like an example that Jay was actually just mentioning of whole like filtering of your data and like not having to pull it local to do that filtering. So this is like, give me a sample that has 10 documents over this almost 200,000 documents. So if you just want like a sample of your data, that's really quick. Here's 10 documents right here with all the full fields in them. And then if you were to run it again, you get like another random sample. And then there's also, you can do, if I just did grade. So if you only want, for example, I only want ones that have a grade of B. And so this doesn't even pull it locally. I'm just applying this filter and I'm running it. And it'll show you a little preview of the data that would come back. So like all of these, for example, have B, and it cuts it off because that's how a repr in data frames would look like. But see, a lot less rows are being returned. And so if I were to run two pandas there, that would give you that result. But then you can also combine these into like, let's see if I remember this. Box, there we go. So if I put some parens just so it's easier to parse mentally, I believe that should work. So this will give you even fewer. And so what this is doing in the background is it's essentially maintaining a query DSL, which is like the query language that Elasticsearch uses. It's maintaining that, and it's also maintaining a task graph that has like pre-processing, run the query, and then post-processing. And so every time you do something to your data frame, it kind of like adds on to that, like those two values there, the task graph and the query DSL. And then when you actually say, okay, now I want my values, it'll execute that task graph, which includes making a search to Elasticsearch or an aggregation, and then post-processing all those results into pandas. And so anytime that you do like an aggregation, because the results are like smaller, if that makes sense, like you're not going to get millions of results in theory from an aggregation. You're just going to get like the subset that you wanted because they're all collated together. Anytime we do that, we actually return you back a pandas data frame because we can, right? It's a lot safer to do that because your data is a lot smaller. But in this case, this is actually like an Elot data frame, but it kind of has that immutability part of pandas that people like, where like if you were to, do, I want to change my data frame, I want to like assign this as data frame 2, like you could totally just do that. And then data frame 2 would then forever have this filter applied to it. That's something that Elon also does. It's like, goes back to what you were talking about earlier, actually, about combining the aspects of both so that they like mix together nicely in a way that makes sense. Immutability is another one of those things. So yeah, I've been rambling for a while, so go ahead.
No, you're good. And I think with that, we can even kind of go into the idea of querying, because you have, again, we mentioned this earlier, there are kind of two ideas when you use the word query when you're talking about data frames and with Elon. Like you have the pandas version of query, which is a very Boolean-like effort, very similar to what we're doing now. In a sense, you are querying, I want all of the rows where the grade is equal to B and the borough is the Bronx. You could turn that into, df.query, was it grade equals B? I don't know why you would do that when you could just do this instead, but you can. But yeah, one of the things that I noticed there is you have a good example of, in those violations, everything starts with like violations, to be included is this. What if it was just something like there was a rat and it's like, all right, I want to know like every restaurant where there was a rat sighting. You couldn't necessarily say like, query rat in this row without it being a super taxing effort. But you could do it with ES query, which is applying the power of Elasticsearch onto your data frames.
Yeah, so I'll avoid embarrassing any businesses with rat sightings. So to show off kind of like the full power, like this is where Elot kind of diverges from just being like, okay, we're just going to be a drop-in for pandas. We're going to add some more as well that is Elasticsearch flavored. And so every time that you see like an ES prefix, that means that it's like an additional thing that Elot is doing. So if you're looking for like Elasticsearch specific stuff, you can always start with the ES prefix. And so this is essentially just adding on to, when I was talking about the query DSL before, it's adding on to that internal query DSL, this query, which is just like a raw Elasticsearch query. But you can do a lot more with Elasticsearch than you can with pandas. For example, geodistance. So there's geodistance queries. You can set a point on a map and say, I want every restaurant that's 50 meters away. And this one is just pulling the cuisine description, but you can also pull like business. And then you can just run it. And within that point from 50 meters, here are all of the entries and the number of times that they show up in this log. So KFC, Burger King, all of that. And then another one, which kind of leans in more into the whole like full text search capability. So example here, if you have just like this is taco, like if you just search for tacos, like you could also do this by like, oh, is the word tacos in the word business? And like, that's an easy thing to do. Like the word tacos is there. Okay, fine. But Elasticsearch is smarter than that. It has like a deeper understanding of languages. And so if you change the analyzer from the default one, which is usually very simple, it just kind of removes white space and does that stuff. You can have things like stemming. So the analyzer is English now, and now if I run it, it won't just do like a simple, is the word tacos in the name? It'll also do stemming. So you get taco. So this is like more of a like data plus typos and things that are similar and like same stems. So like verb tenses, all of that is kind of built into it. And so you can do this, like this feels pretty native. You know what I mean? Like this doesn't feel like a big deal that I have to like construct this huge query. I'm just kind of giving it a word and telling it that it's English, and then calling to pandas, and then I have a data frame that understands English apparently. So it's really kind of cool to like expose those little tiny pieces of the Elasticsearch API through these like native feeling functions. So we're trying to do that more and more, but the full text search capabilities are really exciting. So
Absolutely. Well, let's actually start wrapping up because we've got about 10 minutes left. I want to make sure that we cover a few things. One, first of all, thank you so much, Seth, for showing this. We still couldn't get to machine learning. I feel bad. I did not distribute my time effectively. I guess my performance reviews will show that. But that said, I know that we've got some folks in the machine learning camp at Elastic that are on the stream watching now. So be looking forward to a ping from me in Slack that, hey, you want to come onto the stream and show us some of the machine learning stuff that you're doing? Maybe we'll bring back Elot. But again, Seth, thank you so much for showing us all of this. Also, we got a few more minutes left. So if people have questions about Elon, its capabilities, about working with the clients at Elastic, I remind everybody, our clients are open source. So I'm going to throw it up again, github.com/elastic/Elon. If you feel like you have a brilliant idea on how we can improve this, by all means, check that out. But yeah, Seth, was there anything that we can't leave without talking about as we start to wrap up?
I mean, I guess it's fun to always know like what's coming next, right? I think
Okay.
like a couple of like the big things that I think are really important for Elot that are coming next. One is we kind of have our like checklist for getting Elot to general availability. I know that there's been a couple of contributions like working towards that, because right now it's in beta still. I would say it's a pretty stable beta. I would say it's been in beta for a little while. And so like getting over that hump of general availability and making sure we iron out all the problems that still exist, or like all of the things that we haven't resolved. And yeah, I think that's the big one. And then also the like keeping pace with all of the awesome things that are happening in the machine learning space for Elasticsearch. Like, so if you are planning on using machine learning for Elasticsearch, you can just like watch Elot as well, and we'll probably be going, at the same pace that Elasticsearch is. So we're really excited to integrate some more of the APIs there as they develop and as new ones are created.
Absolutely. And I will say, as someone who's been beta testing Elot for basically the entire time I've been at Elastic, like that is, again, it's one of those things that if I'm uploading a lot of data from a CSV file, I'm using Elon. If I'm having to do a query and then like make it presentable to people outside of my organization where they won't have access to Kibana, I'm using Elon and like a Jupyter notebook. Like it is one of those tools that's just so versatile and gives you the ability to surface the data that you're looking for across so many different applications. Like I use it for web data. I use it for just data, I guess. I don't know. Like I've used it for like a lot of public data, and I've recently just got to start playing around with some of the geolocation stuff and figuring out like, hey, if I want to implement a search where I'm searching around an item, adding this incongruent to something like Google's geocoding API, to where you can say, show me all the taco joints around this area, and then get it back in a nice table format that you can then go to. And in this case, even look at some of their reportings of a certain pizza rodent. But, it's at the end of the day, it's like you can come up with so many use cases to just kind of pepper Elon in. And I always learn something new every time we have a conversation around it. So that said, I think we're going to have to do another conversation around Elon in the future. Would you be down for that?
Yeah, definitely. Yeah, have me on anytime.
Awesome. Well, I'm going to take the last couple of minutes to get some of the admin stuff out of the way. Everybody, thank you so much for listening. If you have questions around Elant, you can ask Seth. I'm going to throw up Seth's Twitter handle there. I know he's pretty active on Twitter and pretty helpful as well. Also, you can ask them in our Discuss forum where we have technicians, elasticians, and all the other issues that are out there wanting to help out. Again, I like making up for it. It's fine. And of course, if you want to keep up with what's going on in the community, we do this weekly live stream every Tuesday, almost every Tuesday, currently every Tuesday. You can go to community.elastic.co. Make sure you sign up for the Amer virtual user group where it's not just this live stream. There are plenty of other events that happen all throughout the week. I think we have an upcoming one on Limitless XDR in the future, like in a couple of days. But next week, we're going to be talking with Enrico Zimwell from the PHP client, which is awesome because I know there are a lot of folks out there that are still rocking PHP, still rocking Laravel, and I want to make sure that we have some content for them as well. But again, Seth, thank you so much for being my awesome guest. And until next time, everybody have a great week.